in two parts. So are you ready to go? So let us start with Larif, and then we'll try and finish in time. So you have about 20 minutes between you. Yes, you do. And I will definitely tell one of you the time is up. No, so try and be reasonably quick so Nishanka can get on, and 20 odd minutes.
Thank you, everybody, and I'm going to dive right in. So the Sri Lanka project has a fairly large number of institutions that are involved, and many people who have got involved. So coordination and putting things together is a lot of work. But we're fortunate to have a lot of young people involved and engaged in the work. Among the people who have come here, we have about a dozen folks here, and some of them are doing double duty in different areas of the work. In terms of the work coverage, we have, these are the rice growing regions in the country, and the slightly brown districts are where the project work is going on, with fast track going on there. And for sugarcane, these are the regions which have sugarcane going on. And so most of our work has been concentrated here. And in the different colors in the red, you have the places where you have field data for sugarcane, and in the green for rice. Dr. Nishanka will be talking later about the fast track work for Kurunegala, but there was also parallel work going on in a neighboring location at Kadavaramulla, in Mathura in the south. So the fast track was going on here in Mathura in the south, and some work is going on here in Anuradhapura in Ampara, so that we got the regional coverage. Data collection was a big part of the work that we have been doing. Similarly, in the sugarcane areas, there is work going on in this district and also for these two districts. So in terms of the climate work, I think that we have the work done with the assistance of Alex and Sonali for 5 or 6 districts, and I think we are reasonably well on our way in terms of producing the time series and looking at them for the base period and the future. In this case, the RCP 8.5 in the 2040 to 2070 period. Similarly, so that was for Tmax, and this is for rainfall. One of the issues that we have is that we don't really see many trends, and in fact, in the map that Cynthia showed, I think that Alex put, it shows that rainfall is actually increasing in Sri Lanka, but in reality, what we find is in the last 30 years or so, there's been a decrease. So there's huge uncertainty in how we deal with climate. Right. So crop modeling work for rice and sugarcane has been going on, and here I have listed the places that there has been work on, and Dr. Nishanka will add a few more places as well. And I am going to skip the details of the places where the work was done, except to say these are the varieties and these are the seasons, and we managed to get the kind of data that you need for adequate. Soil data is quite not only available but also accessible. I mean, this is often a problem for the different locations. So we don't have any problem with the crop or with the climate data. I'll skip that and skip that as well. The genetic coefficients, I think I will leave this also for Dr. Nishanka to talk about, but in our initial work, we used genetic coefficients that was derived with the help of Dr. Veerapon in a published paper, and for about 5 varieties. And for sugarcane, similarly, there are 3 varieties that is quite prevalent. This is variety developed in Coimbatore and one in Mauritius, and there are a few varieties in Sri Lanka. So the data for that have been assembled and have been used to generate, the time series data, for leaf area index, tillers, and all of that. And it has been used to generate genetic parameters for sugarcane as well. More details, I think, will follow in each of the regional groups. Similarly, the distribution of simulated years, that was done, DSAT has been used here quite a bit. And then we've also, with the help of Sonali, we attended a workshop in Hyderabad where we've been able to put together future climate scenarios incorporated with IT tools into DSAT so that we can get all of these outputs. We got all of these output and learned how to get it, but I don't think we really looked at it yet. So I think this is something that, yeah. So again, this is, so Dr. Nisaka was actually leading the fast track, but there was work going on because there's a large team in parallel for sugarcane and also for rice. And I'm going to skip this so that I can save some time. And the TOMD analysis was also done for this location in Kadavaramilla by a couple of folks at the back. The youngest guy, he says, I don't think he's the youngest guy, right? So, the gain losses curves not only for the current, for the future scenarios with access and MyRock, which was recommended to us by the climate team. RAP scenario was also developed. I don't think that we are as far along in this process as we could be, but we developed it internally just so that we could get our tools and work going on, and I think more work needs to be done. But what we did was we went to all the established documents, the government policy documents, and which talk about self-sufficiency in rice and promoting high yield and drought and flood tolerant rice and decreasing the cost of organic fertilizers and so on. In terms of stakeholder engagement, I think we have been doing a lot, but it's not comprehensive. I think we have engaged with the national policy making organizations, individuals, and because I don't think we really have results to show them to engage as yet. But also we are consulted with the 3 of the main agricultural agencies in the country that are undertaking work and really coordinating. There are lots of other smaller agencies or even bigger agencies that are involved, but these are critical 3 agencies for rice and sugarcane. The Department of Agriculture, the Sugarcane Research Institute, and the River Basin Management Authority, the Mahavali Authority, which actually they do comprehensive management and consult extension services and support. And it accounts for 1/3 of the rice production in the country. It tends to be better managed than the rest of the areas. And this was a workshop, and I guess you see Mr. Somewhere, this was the workshop that was held at the Sugarcane Research Institute. Mr. Cyril is here, and Dr. Kirti Pal, who is also attending, is here. So they're talking to all these industry representatives. There's quite a bit of engagement with the 3 or 4 industry representatives. Then, through our farmer surveys and we got engaged with the River Basin Authority officials at one of the systems, as they call it. And this is Erandika, who's attending this workshop, talking to the farmers, and then they also talk to the block managers and the field assistants and all of that. And that engagement also gave us some insight. Similarly, Professor Veerasinghe, who is sitting there, is running an integrated project to incorporate climate information and climate change information in a district, river basin based, almost a district based, right, management project. You might see Daniel Wallach. He also managed to attend that, or we managed to catch him there, and his team who came to help us with a STICS training workshop. And this is like the district, the government agent sharing a session which brings together folks from the different, I don't think it was climate, but all the different relevant agencies that are involved in water management and agricultural management in that district. So on top of that, I think one of the things that we've been working is on the IT side is to the local Sugarcane Research Institute has developed a sugarcane model and are keen to sort of make it, upgrade it and use it for AgMed. And we've actually got it working, and Sanjay Ratnakar, who is at the back, he's actually got it working, and we hope to get input as to how we can develop it further. And similarly, we've always talked of putting local economic models together. Fortunately, Dr. Keith Palu, who's sitting at the back, has actually developed a model for the integrated sugarcane industry, which includes the farmers, each of the industries, and there are 3 or 4 industries, the external market forces and all of that in a quite a comprehensive way. It's a stochastic model, so we've again re-implemented it because I think the files were stuck in some old diskettes and so on. So it has been re-implemented, and we hope to be able to adapt. I mean, we've also started, being able to put in AgMe formats into this. I mean, the data in AgMe formats and getting it in AgMe output as well as in AgMe formats. And so we are excited about this as well. So we'll skip that. And I'll call Dr. Nisankar to talk about the fast track. And so the summary of this work, why don't you come up? Yeah, the summary of this work is that the fast track was completed for Kurnagal along with work done in parallel. Integrated work is going on. Accessing data sets took a long time for us and making it available. And there is, progress with moving the GIS and IT.
Okay, thank you very much. Okay, I will go through how many minutes?
You can have 10 minutes.
Okay, the rice growing area is very diverse, so that is why you see a diversity. For the fast track, we use Kurnagal district because it is the area-wise largest district, and also a lot of farmers involved in both rain-fed as well as irrigated rice culture. And the dark blue color showing the district where we focus on the fast track, and the red dot is the place where the Rice Research Development Institute is there, because one reason why I select that is the data availability of research information availability on the variety trial. So then we got the climate data from FED, and when we summarize over the future scenario situations, temperature maximum is going to be increased by 1.57, minimum 1.65, and the average 1.61. But rainfall, there is no significant difference. That is what we have been observing. Slight changes are there, but the variability is sort of changing. So then I would like to express the succession over the fast track. We started with the preliminary sort of knowledge, and we submit the first report on March 11. In that, four varieties were used because we got the farmers' information and we selected the varieties that farmers are used most. And for the for the calibration, in that case, we had only one season. That is what Larry also highlighted, Dr. Veerapawan's data set. It was a one season, 2000 year data set, and we calculate the coefficient manually. When we came to ICRISAT, and Ken Booty and others suggested give a lot of input onto improvement, and based on that, actually we then ran the auto run for 6,000 times, and also the management decisions changed and improved from what we submitted at first to the second phase. So then the third phase, after Dubai meeting and also the stick training, Daniel, and he suggested rather than concentrating on the one season data, why don't you look for, if you have other research information, then we explore. Actually, luckily we have the director with us of the field crop research, and also he has been the person doing a lot of variety trial in the Rice Research Institute. And all these for BG 300, I mean 4 varieties, we have the experimental data from 5 experiments, and then they have the coordinated research trials. They are also experiment, but they are not monitoring the different phenological stages like that in detail, but planting date, flowering date, physiological maturity, and the yield was there. So we use that for the validation purposes. So then again Daniel suggested why not go for two sites. So then Batanakoda is the Rice Research Institute, and Mahailopalam is the Field Crop Research Institute. They try the varieties at that site as well. We use both for the validation. Calibration was done based on the experimental data. For these, we have 3 months, BG 300 is 3-month variety, 357 means 3.5 month or variety. So this is, basically how the varietal calibration and evaluation is done. So then we developed the genetic coefficient for each trial, right? For example, 2007 high fertilizer, Yala season, we have 2 seasons, Yala and Maha, and then we got the genetic coefficient, and then using that we ran the validation for all the other coordinated research trial. So then we plot those with the observed versus the simulated, and we select the one with the lowest root mean square error for the genetic coefficient to be used for the farmer simulated or the farmer information. So this is what we did, and actually we concentrated mainly on the final yield, but also give the consideration for the maturity dates and also the our experience to see whether with these calibrations are giving the reasonable output. So based on that, we selected the genetic coefficient for each and every variety. So then. Then again, we noticed with the preliminary the fast track submission, we did not consider about the soil variation of the district we have considered. So we came to know that there are 3 major soil types. So then we group the farmers based on the soil variation, and then we input those variation into the model and then calculate the farmer yield, because earlier we observed there is a huge variation, and also sometimes simulated is very low than the observed. We found that it is due to the soil variation, and we corrected that at the 3rd phase improvement. So then again, this is how the yield observed versus simulated for the farm, the first graph, and then the second one. Even now we are doing what we did all up to here is the rain-fed agriculture, right? Sorry, irrigated agriculture. So then we got the information for rain-fed as well. All these green square represent the farmer yield for the rain-fed condition as well. Now we are doing it, we haven't finalized it yet. So then this is the historical farmer yield versus the future future scenario with no adaptation. Then we observed physical reduction of farmer future rice production overall 2 seasons. Once you get the total is 14%, and for both season, this is the for both season average of both season irrigated farming. Rain-fed we are doing right now. And when the bias calculation is done, it came to about 0.75, and the climate effect was 40%. And then after that, we had a series of stakeholders. We talked to farmers in the dry zone, leading farmers, and then we had meeting with the research officers in the dry zone agriculture, and also with the university researchers who are involved in the rice farming system, and also the research officers from the Department of Agriculture, and also decision makers. And a series of meetings we had. This is the farmer meeting we had in the dry zone, And then we even had the group discussion, and we got a lot of information about the variety response to climate variation, and we came to know, I mean, certain varieties, like we use DG358, one variety, they call it as now empty variety, because they found that more empty seeds are produced because it is going to coincide with the high temperature region, high temperature period with the flowering. So BG300, which is the 3-month-old variety, I mean, they are cultivating now because they can resist it more. So we actually choose those, their ideas as well for the adaptation scenarios. So this actually, we had a meeting with the research officers in the Field Crop Research Institute at the annual symposium. We had a separate symposium, I mean, for that. And we had the, again, this is the meeting at the director of the Rice Research Institute and the research term. We get their own views regarding what we should be doing in the event of climate change and the rice yield decrease. So these are the proposed adaptation measures, short term and medium term. Adjusting growing season is one option, and the screening existing varieties for heat, drought tolerance, and management improvement like organic matter incorporation, increased water and nutrient efficiency. Now there is a trend for going for high efficiency fertilizers, and then the long term is like this. Series of varietal improvement, things like that. So then with that we selected 4 scenarios: adapting planting day, adjusting planting day, advanced 1 week, delayed 1 week, and also with the experience and the research information we select one variety BG300 and simulate the yield how it is going to be in the future. So we observed, I mean, the different scenarios were considered, and with that we choose the best option, and we came to know that when the planting is delayed by 1 week, the overall yield is going to be increased by and also with the use of BG350, like short duration variety, there is an additional advantage of increase in the yield. So this is what we observe scenarios. The baseline is the dotted back line, and then the red line planting, late planting. Interaction means the top purple line is the delayed planting with the use of tolerant varieties. This is what we observed regarding the adaptation for the different scenarios of adaptation. So again, there is a nice variation between Yala and Maha, and once you get the overall, so using delayed planting with the tolerant, I mean, right now that information is available regarding that variety, the BG300 is relatively tolerant, and we get added advantage, I mean, higher yield even under climate change conditions. So this is what we observe. So then the fast track, I mean, Dr. Heyrat will cover these parts. So we observe overall net losses of without adaptation 6.19%, and with the adaptation, with no adaptation, adapters is going to be like 11% reduction. With the adaptation, farmers are going to be benefited, and also the poverty index is going to be reduced by up to 3.8. If adaptation is not used, is going to be increased to about 61%. So this is what we have already done. So we are going to next. The calibration is done. We have fine-tuned the DSAT related activities. So we will going to be going to other major rice growing areas. So in here, so we always give the priority for the capacity building of young researchers. So we select research, for this study we get the help from the Department of Agriculture and universities. We all the time use them for these modeling activities and give training. And also must thank the Daniel, and we had a nice stick training program for capacity building. We are going to repeat something like that for the DSET and the upstream as well in the future. This is what, in a nutshell, what we have regarding the fast track. Thank you.
All right. thank you and no, thank you very much to both. We've given them some extra time, so I'm not going to entertain any questions immediately. If we have a bit of time at the end, and we may have about 15 minutes, then I'll allow you to come back with some questions. So can we ask South Asia, Prof? Ready to go? I should say that I rather forced Dr. Nishankar and Larif to keep it short since they had two presentations, but you can see